Hello students, welcome to Sourav Sir's classes. Today we are going to solve a IIT JAM Mathematical Statistics paper of the year 2017. We all know that IIT conducts mathematical statistics in JAM examination, that is the joint admission test for MSc. This is an admission test for MSc in various IIT and NITs. Today we are going to solve a mathematical statistics paper and our problem is this. This is our problem. This is a problem on the sequence and we are to solve it. Let un equals to 4 minus 1 by n to the power minus 1 to the power 1 by n, where n is a natural number or n belongs to a natural number, and let L equals to limit n tends to infinity un. And which of the following statement is true? As this is a MCQ problem, there are 4 options and we have to choose the correct option from these 4 options, and only one option is correct. And now we have to solve it. Solution. Given that un equals to 4 minus 1 by n whole to the power minus 1 to the power n by n, where n is belongs to a natural number, and L is equals to limit n tends to infinity un. Clearly un is a positive number, positive sequence for all n belongs to capital N or natural number. And now we have to take log base e on both the sides, and we get, taking log base e on the both side, of 1, we get log base e un minus 1 to the power n by n log base e 4 minus 1 by n. Now we have to take limit in the both side. It is limit n tends to infinity log base e un. We can write ln also. In the let limit n tends to infinity log base e un and limit n tends to infinity minus 1 to the power n by n. This is n, and log base e 4 minus 1 by n. Okay. Now we know that limit can be multiplied with these 2 portions, that is limit n tends to infinity minus 1 to the power n by n is the one portion, and another one is n tends to infinity log base e 4 minus 1 by n. And we know that this one is 0 because limit n tends to infinity 1 by n is 0, and limit n tends to infinity log base e 4 minus 1 by n is nothing but multiplied by log base e 4. Okay, and this is 0. Sorry for the inconvenience. Yes, implies sign. We get limit n tends to infinity log base e un equals to 0. Then we have limit n tends to infinity un is equals to L. Now we have to apply the nth term test to get the sequence is convergent or divergent. That is, limit n tends to infinity un equals to 8. We assume it. We assume that limit n tends to infinity un equals to L, implies limit n tends to infinity e to the power log base e un we can write in this form, because e to the power log base e un is un, implies e to the power limit n tends to infinity log base e un is equals to L. As we can see that limit n tends to infinity log base e un equals to 0, then this portion is 0. Hence e to the power 0 is equals to L, that is L equals to 1, which is not equals to 0. Then by nth term test, then by the nth term test, we get that sum over un is divergent, because we know that from the nth term test a sequence which is equals to L, that is limit n tends to infinity un equals to L. If L is not equals to 0, then sum over un, that the series, that is the sum over n equals to 1 to infinity un, must be divergent. By the nth term test, limit n tends to infinity un is equals to L, which is not equals to 0. This implies the series sum over n equals to 1 to infinity un is divergent. Hence our correct option is D, that is L equals to 1 and sum over un is divergent. The correct option. Here the key theorem is the nth term test theorem. You have to memorize it to solve this problem. Now we go to the next problem. And the problem is like this. Let x be a continuous random variable with probability density function. This the given probability density function of the random variable, of the continuous random variable, that is fx equals to 0. If x is less than equals to 0, x cube. If x is 0 to 1 and if x is greater than 1, then 3 by x to the power 5. And we are to find the probability that the random variable, that is a continuous random variable, which is from half to 2 is equals, and we given 4 options, and we are to choose the right option from these 4 options. And how can we solve it? Let's see. The required probability is given by the required probability is given by probability x from half to 2, and we are given the PDF, so we are to just integrate from half to 2 fx dx. Simple. It is a basic concept to get the probability from a given probability density function. That is integration half to 2 we factorize it from half to 1 and 1 to 2 fx dx. Now from half to 1 we can see that fx has the value x cube, because half is strictly greater than 0 and x from 0 to 1 takes the value x cube for fx. That is from half to 1 fx takes the value x cube and the dx, and from 1 to 2 fx takes the value 3 by x to the power 5 dx. This is our probability. Yes, all okay. Half to 2 x cube dx plus 1 to 2. We write it again for our own convenience. X to the power 4 by 4. This is a simple formula of integration, that is x to the power n dx. Integration x to the power n dx is nothing but x to the power n plus 1 by n plus 1. And in the next part we get 3. Here x to the power minus 5, that is x to the power minus 4 by minus 4. Okay? Yes. And then from 1 to 2. Then we get 1 by 4 into 1 minus half to the power 4. That is 1 by 4. Here, sorry, it is 1. It should be 1 because we factorize the limit. Half to 1, 1 to 2. Here half to 1, 1 to 2, and here half to 1, 1 to 2. That is 1 minus half to the power 4, and here we get 3 by 4, 1 minus half to the power 4. Okay, and now this is nothing but 1 by 4, 1 minus 1 by 16, and plus 3 by 4 into 1 minus 16. After taking 8, 1 into 1 minus 1 by 16, we get multiplied by 1 by 4 plus 3 by 4. And it is nothing but 16 minus 1, that is 15 by 16 into 1, that is 3 plus 4, 4 divided by 4, and 4 cancels out, and we get 15 by 16 as answer. So our right answer is the A option. A is the correct option. the correct option. Okay, that's all for today.